Okay, we are continuing with more mathematics. So we are going to be picking a couple of questions from our pack of questions. And I must indicate that there are a lot of material I'm planning to use to make sure that we get all the mathematical skills that are required to be sharp when it comes to this. But our discussion today and my aim is to finish probability. So I want us to cruise slowly through the probability for the next 2 hours. So yeah, um, I'll try to be faster, but you'll have your own time to learn the probability with me. So you will let me know where you understand, where you don't. But also, I will give you some exercises to try so that I can see if you follow or you don't. Going through this. Right, so we continue. But we shall be looking at probability today. Right, looking at probability today, there's a form of probability that we're going to be focusing on. The form of probability that uses Venn diagrams and the one that doesn't use a lot of the Venn diagrams. Right, so we are focusing on this one. Right, so the couple of worksheets, obviously, we shall focus on as grade 11 learners. We are focusing today on the targeted worksheet 2, which is must be done in about 60 minutes. But the topic today is probability, the ability to do calculations involving Venn diagrams and probability. This paper consists of 4 questions. There is a question. I need to confirm if this question is visible. Are you able to see the screen or not?
Yes, I can.
Okay, thank you so much. All right, there's another student called Ayanda that might join us. I'm sure the student is still preparing. He's also a very, very energetic and very active grade 11 learner. Was brought to me by the national examiner and said, please train this student and make sure the student understands grade 11 mathematics as they're going to be moving to matric next year. Right, so we're good. We're good. All right. Question 1 is about a survey. Okay, here's Ayanda. Right. Question 1 is about a survey. Some of the questions might look similar to what we looked at, but today I'm trying to go really fast, but also to do as many questions as possible. So, yeah, be ready to get along with us so that you can make the most of these things. A survey was conducted among grade 11 learners on the subjects they do at school. Okay, I had lost the learner. I had lost Ayanda, but now I have Ayanda back. Right, so a survey was conducted among grade 11 learners on the subjects they do at school. The survey revealed the following: 8 do all the 3 subjects of mathematics, physics, and accounting. 12 do mathematics and physics. 5 do physics and accounting, but not mathematics. X do mathematics, accounting, but not physics. 61 do mathematics, 19 do physics, 75 do accounting, 14 do none of the subjects. The question is, you need to draw a Venn diagram to illustrate the information above. Then we proceed to find X and other things there. Okay, so we are looking at targeted worksheet 2. Right. So the question then is, how do we find this? We're going to solve as many questions as possible. Right. Let's get started. Right. To draw the Venn diagram on this here, targeted worksheet 2 is our focus today. And so we shall do a lot of the Venn diagram questions and we shall practice a billion times. So stay tuned and stay ready. Stay tuned and stay ready. Right, so here we go. We do 1.1, so we're gonna do the Venn diagram. Here is the Venn diagram. A survey was conducted among grade 11 learners. Okay, I'm losing this learner. I don't know why. Okay, right. A survey was conducted among the grade 11 learners on the subjects they do at school. The survey revealed the following: 8 do all 3 subjects of mathematics, physics, and accounting. So you have this one here. Okay, so we're gonna do the events. There's an event here, another event here, another event here. So 8 do all 3 subjects of mathematics, physics, and accounting. So if this one is the event of those who do mathematics, physics, accounting A, 8 do all 3. So if 8 do all 3, the 8 will be here. They do all 3. All mathematics, physics, and accounting. 12 do mathematics and physics. If 12 do mathematics and physics, it therefore means that here we need to put 4, because 4 plus 8 is 12 of those who do math and physics. 4 plus 8 is 12. So we are done with this one and we are done with this one. 5 do mathematics, 5 do physics and accounting, but not mathematics. So let's look at the 5 students who do physics and accounting. Physics, accounting, the 5. X do mathematics and accounting, but not physics. They do mathematics and accounting, but they do not do physics. So in other words, they are here. Okay. Now, 61 do mathematics. Okay, you know the fact that 61 do mathematics and this. Okay, 61 do mathematics, it means that in this event, everything is 61. Okay, you have 61 learners here. 19 do physics. You also have 19 of those who do physics, but everything. Okay, the physics ones will be easy because there's no x in the physics. So 4 plus 8 is what? Is 12. 12 plus 5 is what? Is 17. So 17 plus 2. So if they say 19 do physics, so it means therefore you should have 4 plus 8, which is 12, plus 5, which is 17, plus 2, which is 19. Meaning the 19 who do physics are all there. 75 to accounting. So now, obviously, you need some work here because those who do accounting, there's an X. So yeah, we're gonna deal with that one. We're gonna deal with that part. We're gonna deal actually with that part. Okay. Let's do some calculations here. Let's do mathematics. We're doing mathematics. Okay, those who do mathematics are gonna become what? Those who do mathematics, you can put small m here. So that you have m plus, you add everything here, plus x, m plus x, plus 8 plus 4. So we added everything here. And those who do mathematics are 61, which means M is 49 minus X. So which means M is 49 minus X. But you also have now where they give the totals, like 19 to physics. Okay, we used that part already. 75 to accounting. After 75 to accounting, there's an X. So we need to be very careful there. Okay, because we have that. So which means that we're going to focus also on accounting. Okay, so you have X plus 8 plus 5 plus A is 75 of those who do accounting, which means A is the same as what? The 8 and 5 is 13. So you subtract 13 from 75, you get 62. 62 minus X, which means that here you have 62 minus X, and this is A. So the accounting is there. The question obviously was draw the Venn diagram to illustrate the information above, and that is the Venn diagram. Okay, but we're not done. 14 do none of the subjects. So this 75 for accounting has produced 62 minus X. The 14 do none of the subjects, which means that we have 14 learners that are not in the math group, in the physics group, in the accounting group. They do none of the subjects, but they are also there. Okay, we continue. Let's look at 1.2 now. This Venn diagram is part of 1.1. It's just 1.1. What is 1.2? Calculate the value of X. We can easily find the value of X. To find the value of X, we add everything. Right, we add everything in the Venn diagram. So you have 49 minus X, which is this one, plus 4, everything we're adding, plus 8, plus X, plus 2, plus 5, 62 without X, plus 14. We've added everything and the result must be 100. Okay, the understanding is that here we are doing a survey was conducted among the grade 11 learners. In particular, obviously the question they've just said a survey was conducted among 100 grade 11 learners, so that we're dealing with 100 learners here. And then if you simplify everything here, it's obvious that X is going to become 44 because they said calculate the value of X. So the value of X here becomes 44. Calculate the probability that the learner chosen randomly does only one of these subjects. So obviously the learner chosen at random that actually randomly does only one. If they do only one, so either they do only math or they do only physics or they do only accounting. Right, so obviously you can understand that physics alone is going to be 49 minus 44. What is 49 minus 44? It's 5. 62 minus 44 is 18. So what do we do now? Right. We have 18 plus 2. 18 plus 2 plus 5. Then we divide everything. Okay. We divide everything by 100. So in other words, here we are finding the probability. So this probability is, here you have 62 minus 44, 18, 49 minus 44 is 5, and then 2. And then divide by 100. Right, so if you divide actually by 100 here, what is the answer? 1/4. That is the answer. So the probability is 1/4. And we are done with this question. We'll move to the next question on probability and Venn diagrams. Targeted worksheet 2 focuses on more probability questions. Here is a probability question. We're dealing with the 120 grade 11 learners. The 120 grade 11 learners at the school have 3 extramural activities to choose from. Hiking, chess, and drama. They are allowed to do as many of these activities as they like. So it is possible to do all 3. So a person can do hiking, drama, and chess. I know this question, it looks similar to obviously what we did, but I'm trying to reinforce today. They're allowed to do as many of these activities as they like. So a learner can choose to do hiking and chess with drama. So it is possible to do all 3. Any 2 or any 1 activity, they may also choose not to do any extramural activities at all. The following information describes this situation. X learners take only drama and chess. 32 learners. Okay, now let's draw the Venn diagram so that we can be able to interpret this very well. Because the first question says draw a Venn diagram to represent the information. Let's sketch the Venn diagram. Let us sketch the Venn diagram. Right, so we have this. Okay. X learners take only, okay, let's first do this here. So you're gonna have this one here. X learners take only drama and chess. Okay, let's look at these. So there are those who do hiking H. There are those who do chess. Let's call it C. And there are those who do drama. We call it the letter D. So X learners take only drama and chess. Okay. So let's look at those learners which are only X. They take only drama and chess. Only those. So they don't do hiking those. So they are here. 32 learners take chess. 32 learners take chess. Right. So obviously the point is not saying they're only taking chess, but 32 take chess. And the idea, therefore, is we can't quite allocate this one yet because it's not only chess, but yeah, we keep it for now. 40 learners take only drama. This is good. Only drama means you can put the 40 here. So, but it has nothing to do with hiking and chess. It's only drama. So this one is nice and sorted. 6 learners take hiking, chess, but not drama. Okay, let's look at the 6 learners. They take hiking and chess, but they don't do drama. Okay, hiking and chess, but they don't do drama. So those are 6 of them. So in other words, those are sitting here. So here and there. 17 learners take chess and drama. Okay, if you get a 17 learners that take chess and drama, let's look at that one there. So chess and drama, those learners are exactly 17 of them. Right, so what do we know? Obviously, we know that those who take chess and drama but not hiking are X. Right. Moreover, we therefore now know that 17 learners take chess and drama. So in other words, when you look at chess and drama, there are 17. So they're going to be 17 here. This one is only X. So this one is going to be 17 minus X. 17 minus X. Just make that very clear. 17 minus X. We continue. Okay, so it's 17 minus X. Next. So we're done with these ones that take 17 take chess and drama. So when it comes to chess and drama, there are 17 because when you add this one, the 17 minus X plus X is going to produce 17. So yeah, 65 learners take drama. So in other words, here we're going to actually require 65 of them. So we're going to obviously be very careful there. But yeah, we're going to use it. 53 learners take hiking. Right, if you have 53 learners that take hiking, we're also going to use the hiking part. And so we reserve this one. 6 learners do not take any of the extramural activities. So the 6 learners do not take anything. So they are here outside. Let's do some calculations here. So we're going to do, there are some totals we had not considered, like 65 learners take drama. And like the 32 learners that take chess. Let's look at chess. Chess, 32 of them. So we can put this one small c. It's going to be 6 plus 17 minus x plus x plus c equals 32. Which means chess is 9. So it means there are 9 here. Okay, but we're also going to consider drama. Let's look at drama. So looking at drama, drama is this one. Okay. 65 learners take drama. But we don't know this one. Let's call it M, small m. So that now we're going to add everything for the drama. So for the drama, we're going to have m plus 17 minus x plus x plus 40. Okay, so we have this. So want to get, from the drama, we're going to get m. If you simplify everything here, it means m equals 8. So which means therefore here you have 8. Next. Let's look at those who do hiking. Let's focus on hiking. There are 53 of those who do hiking. So if you do hiking part, the hiking is this one. Okay, you can call this one lowercase h. So now we have h plus 6 plus 17 minus x plus 8 is equal to 53. So h is what? You will realize that if you solve everything here, h is actually 22. H is 22 plus x, like that. So in the place of h here, you can put 22 plus x. So we are pretty much done with the Venn diagram. So everything, every region, this region, that region, that we have a total of 8 regions. 1, 2, 3, 4, 5, 6, 7, 8 outside. So all those regions are filled. So yeah, determine how many learners take only drama and chess. Only drama and chess, but not hiking. So we need to solve for x. Let's solve for x. How do we solve for x? Now, to solve for x in 2.2, we proceed as follows. Right, so I want to find x, so we start by saying 22. 22 plus x, which is this one here. Plus 6 plus 9 plus 17 minus x plus x plus 40 plus 8 plus 6 equals 120. So we're dealing with 120 learners. Now, the meaning, therefore, out of this, right, so right. So x becomes 120. (120 minus 108), which is 12. Because now we're to solve for x, so we're just solving for x here. This number is 22, this one. So which means x is 12. Okay, some of the questions like 2.3 are very easy. What is the probability that a learner has chosen at random, takes all 3 extramural activities? All 3, everything, all 3. So now the learner is going to be there at 17 minus x. So the probability All three. All three activities is going to be 17 minus x, which is total of 120 learners, which is 17. So all of them, this one is where everything is happening. Hiking, chess, and drama. So you have 17 minus the 12, which is the x value, divided by 120, total number of the learners at grade 11. So this 17 minus 12 is 5. 5 out of 120 is 1 out of 24 is a simplified fraction. What is the probability that a learner chosen at random takes drama or hiking? What is the probability that the learner chosen at random takes drama or hiking? Okay, let's look at that one. That is the 2.4 part. So 2.4 is the answer. So we are looking at the probability of drama or hiking. So this is the probability of drama plus the probability of hiking minus the probability of drama and hiking. What is the probability of drama? Right, so to deal with the probability of drama, we add everything in the drama part. So the drama has 40, but also has x, which is 12, which is 52, plus 5, 57, plus 8, 65. So which means this probability, you can proceed horizontal like this. So it is exactly 65 out of 120. The probability of hiking. Okay, this was drama. Hiking is this one. So you add everything in hiking. So it's going to be, you add 12. So this is going to be exactly 34 plus 6, which is 40, plus 5, 45, 53. Over 120. The probability of drama and hiking. Drama and hiking. So obviously at this point, if you're looking at drama and hiking, you're looking at this region. So it's actually 8 you're dealing with 5. So that gives you like 13 over 120. And if you add everything, it becomes the same as 105 over 120. Okay, 105 over 120 is the same as 7 out of 8. We're asking the question, what is the probability of drama or hiking? The probability that the learner chosen at random takes drama or hiking, it is 7 out of 8. You can even express it as a decimal fraction. So we've answered this question here. That was like 120 grade 11 learners. We had to draw the Venn diagram and calculate a couple of probabilities. We've just done that to 2.1, from 2.1 to 2.4. Let's look at the group of the 329 learners. A group of 329 learners from the Western Cape speak English, Afrikaans, or Xhosa, or combinations of the three languages. The results of a language survey conducted in this group were stored on Larry's low-scope computer, but unfortunately his files were corrupted. The following facts are all that he has left. Okay, let's look at this one now. 82 people in the survey speak only English and Afrikaans. But obviously now you need to decide, okay, you decide to let the number of people speaking only English and Xhosa to be X, and help Larry by drawing a Venn diagram to represent the above information. Let's just draw the Venn diagram to help Larry here. Here is the Venn diagram. Right, here is the Venn diagram. Here. Right, let's analyze it like this. So you have this one here. You have this one here. And you have this one here. I need to make it larger a little bit. So let me just get this. Expand it. Right, so you're gonna have this one here. And now you can draw this one here. Something like that. Okay. 82 people in the survey speak only English and Afrikaans. Okay, so obviously you have English, Afrikaans, or Xhosa. So you have English, Afrikaans, or Xhosa. 82 people in the survey speak only English and Afrikaans. Okay, so let's look at that. Only English and Afrikaans and not Xhosa, so those are 82. We put here. 8 people speak only Xhosa and Afrikaans. Only Xhosa and Afrikaans, but they do not speak English. Those are 8 people. So you put them here. Only Xhosa, because they are saying only Xhosa, it means in Afrikaans. So you put them in Xhosa and Afrikaans region, but outside English. English ends here. English ends here. 108 people speak only English. Okay, this is nice. So you have 108 is only English. It does not have anything to do with the other languages. 108 people speak only English. Okay, we are done with that part. 34 people speak Xhosa in English. Let's look at the 34 people who speak Xhosa in English. Right, so obviously 34 people who speak Xhosa in English. What does that mean? Let's analyze it very, very carefully. 34 people who speak Xhosa in English. Not only those, but the 34 people who speak, okay, let's look at Xhosa in English. Here is Xhosa in English, and those people are 34. But you've already decided to let the number of those who only speak English and Xhosa, right? Only English and Xhosa would be here. You call those ones what? X. So which means these other ones here would be 34 minus X. Right, so we're done with this. 143 people speak Afrikaans. Okay, so here you have 143 people who shall deal with that one. 109 people speak Xhosa. We shall deal with that one. Let's first deal with the Afrikaans. Right. So if you deal with the Afrikaans, you can say, because there are 143 of those who speak Afrikaans. Okay, you can call this region A, small a. So you have small a plus, and you add everything around, just within the event of the Afrikaans people. So you have a plus 82 plus 34 minus x plus 8 is equal to 143, which means the a For the Afrikaans, it's going to be 19 minus x. So here you put 19 minus x. Then,
Sorry, sir.
yes, please.
Did you notice that Ayanda is not in the live?
Is it? I did not notice. He has been struggling today. He was on and off. I don't know why. I did not realize. Okay, I'm going to check. Because Ayanda is very interested in learning. But I lost Ayanda. Okay, I'll find out. Maybe there's an issue because she has just been on and off. Maybe it's the network. I don't know because she went out and then she tried to join again and she tried to join for like 2-3 times. I don't know why. I'll investigate. I'll find out. Okay, that's fine.
Okay, sir.
All right. Thank you for actually making me realize something I had not noted. I thought Ayanda was still here. All right. Thanks for letting me know. Okay. Right. So we have this now. So the A is 19 minus X. Okay, now let's deal with, in fact, in particular, is 19 plus X. 19 plus X, because this X is negative. When you bring it across, it becomes plus. Okay. We're dealing with the Afrikaans. Now let's deal also with the Xhosa because there are 109 Xhosa speaking. So Xhosa. Right, so you can just make this one capital X. We already have a small x. So for the Xhosa people now, you're going to have capital X plus the small x, and then you add 34 minus x. Plus x plus 8, which is x, 34 minus x plus 8. The answer for the Xhosa people must be 109. There are 109 Xhosa people. 109 people speak Xhosa. Okay, this is a little bit, it has more words. It's heavily worded. So it's a question of just reading the story and trying to make sense of it and converting the story to mathematics and diagrams and Venn diagrams. So which means capital X is 67. So which means here you're going to get 6-7. Right. So obviously help Larry by drawing a Venn diagram to represent the above information. So that's by and large what we have. Each region here has its own label. Right. Obviously, there's nothing outside there, outside these events. Help Larry by drawing a Venn diagram to represent the above information. For 6 marks, we've done that. Use your Venn diagram to solve for X. Let us solve for X. Let's try to solve for X. Right, trying to solve for X now, we need to add everything here. So let's try to do that. Right, if we try to do that, we're going to have the following. So we start with 108. After that, we add 82. After that, we add 34. After that, we add X plus 8. After that, we add 19 plus X. After that, we add 67. Everything, the total of the learners, a group of 329 people. 329 people. We solve for X. If you solve for X, you realize that X is equal to 11. So you have to use a Venn diagram to solve for X, where you are saying you decide to let the number of people speaking only English and Xhosa to be X. Right, only English and Xhosa to become X. Right, so we have that. What is the probability that a person, selected at random from the group speaks English, Xhosa, and Afrikaans. They speak English, Xhosa, and Afrikaans. So they speak all of them, all three. So you are here. So the probability of the person is speaking English, Afrikaans, and Xhosa is everything here. So what is the everything there? The everything here is going to become you add everything, so it's going to be 34 minus x, and x is 11, divided by the total of the 329 people, which is the same as 23, divided by 329. That is the answer. The probability that a person selected at random from the group speaks English, Afrikaans, and Xhosa is 23 over 329. Okay, let's look at this one. What is the probability that a person selected at random from the group speaks only one language? The probability of the person speaking only one language? Right. Only one language is going to become, so only one language can either be English, or which is 108, or now the 19 plus x, which is 19 plus 11, which is 2030, or you have 67. So the probability of one language, as I indicated, as we saw above, is either 108, or the 67, or the 30. You divide by 329. If you add everything here, it is 205 divided by 329. Okay, so you have that. The probability, what is the probability? What is the probability that the person selected at random from the group speaks two languages only? So the probability of the person that speaks two languages only, right, speaks two languages only. Right, the probability that the person speaks two languages only. Right, so either obviously it's two languages only, it means a person can speak like English and Xhosa. So English and Xhosa, it's going to become what? Or they can speak Afrikaans and Xhosa, which is going to be right, but it's only two. So Afrikaans and Xhosa is going to be only 8 because it's without English. So you have 8, or they speak English and Afrikaans 82, or they speak English and Xhosa, which is without Afrikaans, which is only X, which is 11. So we have those three numbers. So we're going to have the 82 plus 8 plus 11. You saw that in the Venn diagram. Out of 329, and this is 101 divided by 329. So we continue. We continue. Okay, let's look at another question. Here we're looking at a survey. So we've answered this question about the probability question of the 329 people and Lurie, a group of the 329 people from the Western Cape province. So these people are from there. the Western Cape province. Let's look at these ones now. A survey looks at a group of 283 workers were selected. We asked which mode of transport they used to get to work, and the results of the survey were summarized. X workers take a train, they take a bus to get to work, and so on. So, which means that let's analyze this one. We need to draw a Venn diagram. Let's get started with the Venn diagram. So you have this Venn diagram here. Right, so obviously you have three things. You have the train, you have the bus, and you have the taxi, like this. So now you have the train here, you have the bus, you have the taxi. Survey of 283 workers asked in which mode of transport they use to go to work, to get to work. The results of the survey are summarized below. X workers take a train, a bus, and a taxi to get to work. So they take a bus and a taxi to get to work. Okay, let's look at this. X workers take a train, a bus, and a taxi. So they are here, those people. They are here. They are here. So the X people, they take a train, a bus, and a taxi. So they are here. A train, a bus, and a taxi. 110 workers take a train and a taxi. Okay. So if 110 take a train and a taxi, the 110. So which means that obviously here you must have 110 minus X. So this one is taken care of and that is taken care of. 38 workers take a taxi and a bus. Okay, if they take a taxi and a bus and they're 38, this one is already X. So it means that here we're going to have 38 minus X. Next. 32 workers take a train and a bus, but not a taxi. Right. So 32 workers take a train and a bus, but not a taxi. Okay. 32 workers take a train and a bus, but not a taxi. Look at that. So the 32, they take a train and a bus, train and bus, but not a taxi. So 32 is here. What that is this one? 60 get to work by taxi only. 60 get to work by taxi only. So if 60 people get to work by taxi only, okay? Let's look at this. 60 people or 60 get to work by taxi only. Okay, so taxi only is 60, so we can put the 60 here. It's only taxi. One is done very well. 110 workers take a bus. So which means that now the bus, we're going to deal with it. We're going to add everything there. So the bus is going to become 32 plus x plus 38 minus x plus b equals 110. So b is 40. Let's look at the train. So the train is going to become that if you call this big T, so it's going to become, okay, you can call this one big B for the bus. Big T for the train, and then you add for the train. So it's going to be T plus 32 plus X plus T plus 32 plus X plus 110 minus X. Those who take a train are how many? There are actually 172 workers that take a train, which means T is equal to 30. So you have 30. We continue. So each of the regions has been labeled here clearly, and there's nothing outside. Draw a Venn diagram to represent the information, and we have just drawn the Venn diagram to represent the information. Right, so in 4.2, determine the number of workers who take a train, a bus, and a taxi to get to work. So we want to determine X. Let's do that one. So to determine X here, we're gonna do it here. So we need to add everything. So we're gonna add 30 plus 32 plus X plus 110 minus X plus 60 plus 38 minus X plus 40 is equal to 283. Okay, so add everything. So which means X is 310 283 27. So X is 27. In 4.3, what is the probability that the worker picked from the sample takes a train and a bus to get to work? Give your answer as a fraction. We will continue. Right, so in 4.3, what is the probability that the worker picked from the sample takes a train and a bus to get to work? Give your answer as a fraction. So in 4.3, now we are dealing with the probability of a train and a bus. The probability of a train and bus. Right. What is the probability that the worker picked from the sample takes a train and a bus to get to work? If your answer is a fraction. So a train and a bus. So train and bus. So you are dealing with 32 plus X. And X is 27. over the total number of the workers, which is 283. All right, so which is the same as 59 out of 283. Right, so that is the probability of the train in the bus. Okay, if you look at 4.4, what is the probability that the worker picked from the sample takes a bus but not a train? So the probability that they take a bus but not a train. Right, so a bus but not a train. So you look at this very carefully. So they take a bus but not a train. Right, so it means that the bus is going to be 40. It's going to also have the 38 minus x, because now there's no train. So they take a bus, but there's no train, so it's 40 plus the 38 minus x, 27. So you have that out of 283. So the bus, but not a train, is 40 plus 38 minus 27, which is divided by 283. And this is the same as 51 out of 283. Okay, so we've done this question here. You need to watch this video and make sure that you can make sense of this. We've done the survey of the 23 workers and we've drawn this Venn diagram. Okay, and now we're going to proceed with these questions on Venn diagrams, and we shall do a bit more. Right, in my next appearance, I need to rescue one student who just brought to my attention that they are in trouble now. They need urgent ideas. So I'm gonna take a break now because I wanted to go until 8:30. But now I'm just into this discussion for just 1 hour, and there's a student who just interjected and told me that you see, they always leave their things for the last hour. Right. So now, please allow me to. I'm gonna send this video, so I'm gonna apportion the time. As soon as I'm done, I'm gonna check with you if we can continue or we can continue tomorrow. So you let me know. Okay.
Okay, sir.
Yeah, I'll
But
let you
sir,
know. Yes.
can I ask something?
Yes, please.
If the question says, are the events of A and B complementary, does that mean the probability of A and B must add up to 1?
Yes, definitely. Complementary
Okay,
events. It means that the probability of A and B must add up to what? Must add up to the number
to
1.
1.
Yes. Okay, if they're
Okay,
complementary. Okay, because we
yes,
either
sir.
have
Thank you.
complementary. Yeah. Okay, so we shall discuss complementary events in detail. Obviously, as I am going to appear. Right. So yeah. You are on point there. Yeah. Complementary events. We also have independent events and so on. Okay. Yeah. So if 2 events are complementary, I'm gonna mention here. So we say complementary events. That means that the probability of A complement is 1 minus the probability of A. So in other words, obviously the idea is that the events A complement plus A must be 1. So if they're complementary, then you just say 1 minus the other one, whatever, or their sum is 1. Okay, that kind of thing. All right. So these
Okay,
complementary
sir.
events, yeah, they work for the complements. They are complementary. Complementary means there's a complement. What is a complement? It means it's the opposite event. Because if we have an event A, the probability that A does not happen, it's complementary. Okay, because it's the opposite of A. Okay, right, we'll discuss those. Yeah, but thanks a lot then. Yeah, let me just attend to the student. Okay, quickly. Okay,
Okay, sure.
thanks, dear. Well, yeah, I will check with you when I'm done. Okay.
Okay.
Okay, thanks. Goodbye. Bye for now.